Hello, Matt here from ChemistryStudent.com. In this video, we're going to look at the fractional distillation of crude oil. We're going to talk about what the fractional distillation of crude oil actually is, why it's important, and how the process works. Let's go. Crude oil, also called petroleum, is a mixture made up primarily of hydrocarbons, formed over very long time frames from organic matter left over from living organisms, mostly algae and plankton from oceans. The organic material was compressed and squashed with immense temperatures and pressures, forming the compounds present to undergo chemical transformations and get squeezed into porous bedrock. We mostly obtain crude oil by pumping up oil that is trapped under hard rock in what are called reservoirs. The different length hydrocarbons in crude oil are very useful, however they have to be separated out from the crude oil mixture before they can be used for anything. When separated, the different length hydrocarbons have slightly different uses, primarily as different fuels. Turning crude oil from its original state into useful substances is called refining, and the main process used to separate crude oil mixtures is called fractional distillation. The crude oil mixture is heated up and vaporized. The vapor is passed into a fractionating column which has a temperature gradient. The bottom is hot and it gets cooler towards the top. As different length hydrocarbons have different boiling points, they will condense at different heights in the column, turning into a liquid. This happens when the temperature in the column gets cooler than the hydrocarbon's boiling point. By placing valves at different heights in the column, these condensed hydrocarbons can be obtained at different heights, forming what are called fractions. Fractional distillation columns have to be very tall in order to enable the temperature to change gradually up the column, enabling condensation to occur at different heights. Fractions from lower down in the column will contain hydrocarbons that have higher boiling points, longer carbon chains, and fractions from higher up in the column will contain hydrocarbons with lower boiling points, shorter carbon chains. It is important to understand that each fraction will still be a mixture of different compounds. It's just they will all have a similar boiling point, and if they are all similar length hydrocarbons, similar physical properties as a result. For example, color, viscosity, and volatility. The final use of each fraction is based on the properties of the hydrocarbons in it. And although different crude oil types give slightly different fractions, generally crude oil is refined into 6 main categories of hydrocarbons. Moving from the bottom of the column to the top, we have bitumen, which is a thick, viscous and dark liquid used for road surfaces, fuel oil, which is a slightly thinner liquid and used as a fuel for ships and power stations, diesel, again slightly thinner than fuel oil and more easily ignited, meaning it can be used as a fuel for larger engines and some cars. Kerosene, which is thinner again than diesel and is commonly used as a fuel for aeroplanes. Petrol, a very thin and runny liquid that easily ignites, highly flammable, and is used as a fuel for smaller engines and cars. And finally, natural gas, a gaseous fraction that burns very easily and is often used as a heating fuel and for cooking. To make higher quality fuels, each fraction obtained will be further refined and basically distilled again to further separate out different length hydrocarbons in the fraction. This improves the purity and efficiency of the fuels. A process called cracking is often used to help tailor the length of hydrocarbons to a desired length, increasing the proportion of crude oil that can be used for a particular fuel type. The fractional distillation and more widely refinement of crude oil is fundamental for our everyday lives. It is an essential chemical process that our modern world is wholly reliant on. I hope you found this video helpful. Please check out other relevant videos in the links given in the description below and visit ChemistryStudent.com for free notes and revision materials.